Hello. Welcome to this Open Source North speaker series. I'm Isaac Johnson from Medtronic, and today's presentation is full stack CICD of Kubernetes Microservices using DevOps and infrastructure as code. And that photo, if you don't recognize it, was from Open Source North about 2 years ago. So just kind of missing the conference. This is great. I'm so grateful to be able to talk to you today. I definitely wish we could be in person, but that's our times right now. So a little bit about me. I'm originally from Minnesota. Was out in San Diego from about 2010 to 2017. I'm a family guy who really misses movies at the Alamo Drafthouse. I was really happy when we got one here in Woodbury, and it's been closed for a while. I enjoy camping and fishing and being outdoors. I love Death Wish coffee. I put the pictures of my last two laptops off on the right because I tend to find you know a lot about somebody from their laptop lid. And then I also like really, really spicy foods. Everybody knows me for having a fan of some really good pho. In my free time, I create courses for Whiz Labs on DevOps, and I also kind of put all the logos of all the places I've had chances to affect change, and I started my career doing Fortran back at Control Data, so kind of one of the last ones in there, and throughout the years been at a lot of different interesting places, and at Medtronic we're working on kind of the next generation CareLink, so very cloud initiative. It's a lot of fun. I'm a principal software engineer there, though in my heart I consider myself still a cloud solutions architect. That's kind of what I think of myself. So a little disclaimer, I am opinionated. People know me to have strong opinions, and the views expressed here are those of me and don't necessarily reflect my employer or anybody else. So just when I'm talking more for myself than necessarily representing Medtronic. So let's talk about our problem statement. What are we trying to achieve here? Because when I say full stack CICD, I'm biting off quite a lot. What we need, our requirements, is we need to create a fully containerized microservice platform using Kubernetes. We need to use Azure DevOps. That's a thing that we've decided upon. All right, it says that I'm still seeing the title page. We'll give it just a moment. Alex, when you can you confirm that you're seeing the problem statement page now? Interesting, there's a delay. Is it still showing the front page? I can remove my video if that helps at all. All right, I'm getting confirmation from others in the stage chat that we see you move pages. Okay, so we'll just assume that it's good. I'm gonna put back my video. It'd be terrible for me to talk far ahead and then have everybody behind on a couple slides. So I'm just gonna start over a little bit here. The requirements are, we need to create a full containerized microservice platform using Kubernetes. We need to use Azure DevOps, but prefer to use open source solutions whenever possible. And we also need to document all that we do. That way we can scale. Some of our desires is we want cornfields, not flower boxes, and I kind of put that in there for my vegan friends so that I'm not always saying pets and cattle. But we want to create things that it's okay if we destroy them. We don't want to have pets that we have to just keep maintaining. We're going to make mistakes, and we want to fail fast and alert quickly. And lastly, in our desires, whenever possible, we'd prefer to use platforms as a service and software as a service. We don't want to have to build everything that we make. So the proposed solution that we kind of march forward with here is an Azure DevOps YAML pipeline. And by using YAML pipelines, that's where the build pipeline is defined as code, we treat our build layer with the same review and policy rigor as our running code. So if we decide that we need multiple reviewers and it can't be self-approved and we tie to a work item on our code, well, we should have the same kind of quality requirements on our pipelines. We're going to use Azure Virtual Machine Scale Set agent pools and Azure Pipeline pools. We want to use ephemeral hosts. Not, again, this is that whole cornfields and flower boxes. We don't want to have these build agents that we have to hand alter or worry about changes that are on there. We're going to use Azure Key Vault for secrets, and we can leverage Key Vault in YAML tasks, as well as with the library section for classic pipelines. Now, I'm a big fan of Hashi toolset, so obviously there's solutions that involve Hashi Vault, but for this, we're talking about Azure Key Vault. We're going to use Azure Kubernetes Service with AAD-based RBAC, and in doing so, we're going to integrate with our existing ID provider. We don't have another set of credentials we have to manage, like some IAM credentials or tokens. We can log in with the same thing we log into our email with. And thirdly, or not fourthly, we're using Azure Container Registry to store our containers in our Helm charts. So the ACR and AKS tie quite natively together. The part of this equation that isn't a Microsoft product is Hashi Terraform. So for infrastructure as code, and ARM templates have come a long way, but Terraform is still the preferred solution for doing our infrastructure as code layer. So let's kind of talk about in the beginning. So how do we go? I'm not going to pretend like I had all the solutions at the beginning or our team started with the best thing forward. No, we started with some junk. We had an Azure command line client for creating the AKS. We'd write it down or did some draft email. We added, a service principal to view it. We'd create a pipeline for the environment. And then we created like a Git repo. We push some copy there and we'd regex it, and then it wouldn't work. We all of a sudden started blasting away something we shouldn't have done. So we'd regular expression again and jerry rig it. And all of a sudden we have deploying with a PR and the PR request. And then we're tired of waiting for somebody to approve. So we turn off the rules because we have the powers. And then we close off the work item and now we have a new microservice. And you could argue that, yeah, it got the kids to the 7-Eleven, but it was rather an embarrassment in the parking lot. The other thing is, as we started to build things out, we came up with these really clever automations. We had like an automation, and I can make a build pipeline, call another build pipeline, and wait. Well, that build pipeline could be automated and abstracted to call other build pipelines. And when we had just 1 or 2 customers, that was fine. But when we started to have 5 customers, and then I'd have an engineer add 10 more users, and those 10 users had to trigger a deployment of 40 namespaces each, and each of those had different, things regarding Kafka and HBase and all these other tool sets that we had, it fell down bad. And I recall having issues where adding a user would take down all of our concurrent pipelines because it didn't scale. And so one of the things we did early on is start to rethink some of our work item automations. And when we had an automation, we start to use things like a semaphore. So a semaphore is a variable or abstract data type that you kind of say, we have a constrained resource and only one person should use it at a time. And so by implementing a semaphore, it allowed our automations not to step all over each other. We then started to take some of these unique pieces of logic and, like any good programmer, started to turn them into reusable pieces of code. And in YAML pipelines, these are things called templates. So we'd have templates for all these repeated pieces of logic in the automation. Pretty soon we started to create this pattern for our work item automations. And the pattern was we could look for people asking for work with the work item query. And that work item query, and if you use, say, something like Jira, you might do a JQL query and a saved search. Very similar in Azure DevOps, if you're not as familiar with Azure DevOps. We could do that work item query and it would come back with a results set. And because I can do a work item query on the command line, I can get back a list of responsive tickets to that, and then I can ask for the details of those tickets and parse them and process them sequentially. So start to develop these work item automations, asking for, are there any tickets related to onboarding users? Are there any related to microservices? And we really started to pattern these things out. And today we have 5 or 6 different work item automations actively handling user requests. And I wanted to give you guys a piece of code, and I don't expect you to understand everything I'm showing here. The deck will be linked at the end of this talk. but I wanted to kind of explain what a semaphore looks like when you're doing it in Azure DevOps YAML. So what we do here is we ask for a boards query, that's a work item query, and I pass in that ID of my query, and I get back the output. It's always JSON coming back if you want from Azure command line client, and you can parse it out, and I stuff all those IDs into an ID text. And the next step here is I go ahead and ask for my pipeline. So if you see there in the URL at the top, the pipeline has an ID of 1, 2, 3, 4. So in this step, I'm going to ask what are all the running instances of pipeline 1, 2, 3, 4. And I'm going to store that in a text file. Next, I'm going to go ahead and turn that into an environment variable. And what you're going to see there in that first block of bash is that echo VSO. You got to know a little history here. Microsoft really does love to rename things, and Azure DevOps used to be called Visual Studio Team Services, and before that was called Visual Studio Online. And so the VSO is a callback to that early days of Azure DevOps as a tool. And this is how we take some output and make it into an ephemeral variable used by the rest of our pipeline. So I've created this work items, WIS, to process variable with the comma separated list of all the IDs. The next bit of bash is ugly, and I'll admit it's ugly, but it works. And what I do is I take that comma separated list and I turn it into a block of JSON with those 8 or so lines of code. And so that work items of process comes in, and I turn it into a block of, say, so if I had tickets 1, 2, 3, 4, I'd call it process 1, 2, 3, 4 colon work item colon 1, 2, 3, 4, and I just create this nice JSON block of work items to process. The next part of this is I kind of start to blank things out. So if no one came in, if I had no requests at this point in time, I'd do an empty set. So it's just empty braces there at the top. And then this is also where I kind of come back to where I got all those instances. And I see were any of them called not started or in progress. And if so, blank it out. This way, because this pipeline's on a timer checking for work to be done, if it detects that there's other things still running, and this is I usually had this. I usually had like a team lead come in and add 30 onboarding tickets at once, and that run takes an hour to process through. It would stop and just nullify its set. So that second half of the page is really about nullifying the set. And then lastly is this little part about parsing the work item and doing matrix. So Microsoft, when you look up the documentation on using the matrix strategy, they're often talking about breaking down testing for different permutations of Android and iOS and different classes of machines, Windows, Linux, etc. I use matrix to create an arbitrary number of stages to process things. So when I don't know how many stages, this way I can create a run in YAML that might have 30 stages or just one stage. It's 0 to n of all these stages. Now I see that there's no questions yet. I think I'm going to keep going, but I'm going to ask real quick, any questions on this, because I'm going to move on if not. All right, looks like we're doing good. I'm going to keep going. So next we go to our typical infrastructure as code repo. So we created this pattern for our infrastructure as code. I'm going to talk about the Kubernetes service first. I have similar patterns for storage pipelines and whatnot, but the AKS one is probably the most commonly used. We would have a configure folder where we'd have all the things I got to do after I run. Now, I could have done a provisioner in the Terraform and done the same thing and kept everything in the Terraform folder. I could have done that. But I like being able to view the code and view the YAML and know who changed the cluster roles independent of having to parse out, say, some Terraform code that had a provisioner in there. So this is my method of having all the configure code in its own foldering path to process. We have a docs and a pubs folder. I had architected into it named Tommy Bishop who really drove this home. It's one of those life lessons I took with me through all my career, is the idea that documentation is internal facing documentation. It's documentation for us, and publications are documentation for others. And I'm going to talk about that more in a minute. But all my repos will have a docs and a pubs folder. We then have an examples folder. And examples doesn't always have content, but if I have an infrastructure as code repo and I want to be able to hand this off in the future to others, there's oftentimes little examples like how would I add some unique cluster admin. So I'll put in examples things we're not going to run in deployment, but might be leveraged by people later on. Then our Terraform folder is almost always really tight. It's got the main Terraform code, it's got the output Terraform, and then it's got variables. So these are the main pieces of Terraform that I have, and obviously variables in Terraform are settings. They change per run, and the output's going to be outputs that we're going to look at. Then any Git repo I have has a README, and then I have my pipeline file. And this is pretty much constitutes, this was taken actually from one of my real AKS. This is all that's in my infrastructure as code repo. It doesn't have to be any more complicated than this. And here's kind of an example of what one of those YAML files looks like. It's just straight Kubernetes YAML. Here's where I define a cluster role binding. And I'm going to go ahead and map that team cluster admin cluster role to a DL. And this is also why I'm a really big fan of AKS, is with that AD-based RBAC, I can look up the object ID out of Azure Active Directory and give authorization to a DL. And that becomes the lowest common denominator, right? Because when people get added to your company, usually they get added to DL build team or DL our great new project team. So that team of people already exists in your AD. Why not use it for your RBAC? Why have another place to kind of keep a copy of groups? And so we use these groups for management as well as access to various namespaces. I said I would get into documentation versus publication, so allow me to soapbox for just a moment. So the documentation is anything like internal, run books, how-tos, legacy one-offs, maybe some notes on the infrastructure setup. Ooh, you need to make sure that you have Python 3 in order to install the Azure CLI, stuff like that. I've even seen it where teams put their meeting note minutes in the wiki in the docs folder. Pubs or publications are things that are meant to have a general audience, and typically we review those as a team with higher rigor because we have to assume the lowest common denominator is reading it. And we'll reject a PR on spell check on things like that. So it's how-tos for user, frequently asked questions, maybe some of your REST documentation, maybe put some Swagger in there. More information about that which you provide. And status and dashboards. And probably the coolest feature I like with Azure DevOps compared to maybe some other tool sets out there is any of that code that we write as markdown in our Git repo can be exposed as paths in the wiki there for our end users. So what you're seeing here is something pulled out of my Azure DevOps where I'm exposing Git repos, the documentation that's in to my users. So I don't have to have a second wiki. It can be in this system. Let's talk a little bit about the process. So I have AKS and ACR tied together here. So I kind of do them as one lockstep. So the Terraform is going to create the container registry. It's going to create the Kubernetes cluster, and it's going to take care of that networking layer as well. I'm going to do a plan, and I use Azure RM for storage. Now, in a more production level, I'd be using Terraform Cloud and then eventually Terraform Enterprise so I could get Sentinel. But in this instance, I'm leveraging just the open source Terraform. So my state files get stored in Azure RM blob storage in a storage account that I control. We then do an apply, and the apply is going to go ahead and do the work. And the reason we do a plan and apply is I don't assume that I'm just running this for the first time. I might be rerunning this. There might have been a problem. We need to rerun it. So doing Terraform plan finds what's delta between the code and what it finds out in the cloud. And apply applies those changes. So it'll create the cluster and the container registry. And it's in my configure step that I have a little bit of jerry-rigging. And you can see it in the Azure DevOps YAML pipeline if I was to show that. But there's certain things that require an elevated privilege. Due to account controls, I can't create the service principal right there in the Terraform that runs as my cluster. I have to provide that. Therefore, that shells out to something that's a privileged area to create things like service principals and then return back the app registration, client ID, and client secret that then is applied to my cluster. So there's a little post-configuration step, and then it grants that service principal access to the container registry. Therefore, the AKS can talk to the ACR straight up. I don't have to install one of those Docker secrets to connect to my container registry. Lastly, in all of these things, I save any settings I might need to get at later into a key vault. So one of the common cases is a lot of my Kubernetes services will store their credentials to be used in an AKV. So later on in consumer pipelines, when we use this, we can pull them out of AKV to use. Another fun fact that I have is that with each one of these, I have a manual gate there that stops. It just stops right there. It's a manual gate. And it requires my user, or ideally an admin user, to click approve. And if you say yes, it destroys everything it just made. I always have a little trailing destroy. It's like a tail that should never be used unless we have to. And the reason is it's a lot easier for me to simply go in there to the manual gate on those rare occasions to say, ooh, we shouldn't have done that, or ooh, there's a big problem, and say, go, and for it to grab the plan file and all the variables that might have been passed in the beginning and destroy the whole lot of it. And so having that little manual gate with the destroy has saved my hind end a few times when I've created things errantly or was about to. So let's kind of show what this used to look like. So we started doing this with classic pipelines that would have a release that would then trigger out and do this. So the early days of Azure DevOps, we had build pipelines and release pipelines. They were done with a graphical editor. And we could see some of the details that would happen on these. This is a case of one that I created and I destroyed. And because everything is code, you can see at the bottom there from the branch tag that this was based on ticket 33633, and I was creating a ninth cluster of some type. And so I can see why I did something and look to there for the history as well as seeing all the timestamps. We can also see who approved it on the approval gate to say, oh, Isaac went ahead and said, destroy this thing. When we moved to YAML pipelines, we lost a little bit, but you can still see the steps as we kind of go out to create a pipeline here. Again, all the steps are being followed that were before in the classic. They're just now as YAML steps. Now I'm going to check to see if we have any questions. I think we're doing good. All right. I'm going to move on. This is me kind of graphically showing what I just talked through. So I have the infrastructure stages creating the Kubernetes cluster and the ACR there at the top and storing the variables to AKV. And then there's two ways that my consuming pipelines will interact with this Kubernetes cluster. So with the dev pipelines, the bottom half here, on the left-hand side, we'll see cases where my microservice will have a template step that uses a service principal. This is our Azure DevOps service principal. Ask for those variables from AKV, and then I'll set a kubeconfig environment variable and engage with it with standard kubectl commands. So now I'm engaging with my cluster using a file I brought down and decrypted out of Key Vault. The second way I do it, and you can really only do this with a cluster that has a public-facing control plane. So if you have a private Kubernetes cluster where your control plane is 192.168 or something, you're not going to be able to use this environment. But if your Kubernetes cluster does have a public-facing endpoint that Azure DevOps can see, you can use the environment section to look at a namespace and expose it. And the beauty about doing that is when you have environments, you can start to do more interesting things. So an environment, and here's an environment for the Kubernetes cluster that's running behind this curtain in the back room, you can do things like an approval gate. So maybe I say that someone, a defined DL, must hit approve for everything that goes out there. You can also do things like branch control. So maybe I want to define a list of branches. So this is kind of one of the standard Git flow ones, all the things in features, develop, and main, and they must have branch protection. So no unconstrained branches can deploy automatically out to this environment. And this creates that good division of labor, because what you want to do is empower your developers to create new microservices and deploy to Kubernetes. But you also don't want them to deploy to the shared namespace from their private unmanaged branch. This kind of gives that right level of control. My developers in this previous example would only need to know the name homek8.default if default was the name of this namespace. And that's all they need to put in their code to deploy. And if they're approved, then these rules apply whether or not they can go out. And so this kind of creates that nice division of labor. So let's talk about, again, this environment versus service connections, the pros and the cons. So with the environment, we expose just one namespace at a time. And unfortunately, you got to create it interactively. There's no API to do it. It does require an exposed management plane as well. However, it's really easy to view workloads. So here we can see on my home Kubernetes cluster, I installed Ambassador because I now prefer that over Nginx for my ingress. And so that was not something done through Azure DevOps, but it's showing me that it was installed. It also lets me see things like services. So I can view what are all the IP addresses and what are the external IP addresses. And if it was a real AKS, you'd see an actual IP address of something. Here we're just seeing the route into my home cluster. And so you get to see all the services. And my developers really like having the power to see what are all the different microservices they've run, what is the pod IP, and what is the external IP if exposed through an ingress. So some considerations. Kubernetes is not static. Whether it's Elastic Kubernetes Service or Google Kubernetes Engine or Azure Kubernetes Service or any other Kubernetes engine, the supported versions in a region or zone keep changing, and you're going to have to upgrade. There's just no way around it. And if you don't upgrade, if you say, well, no, I don't, well, you're not going to be able to horizontally scale your node pool. They'll say you can't create another node in this region because we don't do 113 anymore. Consider your IP subnets if you're using something like Azure CNI or any non-KubeNet networking. So when your pods are acquiring from the same pool of IPv4 as your nodes and you have one flat network, you can run out of range. And I've encountered this. It took over a year, but I just burned through 2048 IP addresses, and then I've had issues with one particular cluster not scaling out anymore. And how do I handle that? Well, I had to parse up a larger VNet, create new subnets, create new node pools, but now I'm doing things by hand, right? Remember, I talked about cornfields versus flower boxes. I'm now treating it as a flower box. I'm hand editing and adding a node pool with some handmade new VNet subnet range. And so just make sure you have enough IPs if you have a cluster that you plan to keep around for a while and you're not doing KubeNet. The other issue I've encountered is, as much as I fell in love, and still am wildly a fan of AKS AAD-based RBAC, AAD RBAC uses the access token lifetime as defined by your Azure AD. And if you're like a normal build person, and I assume many people are, your admins aren't going to let you have admin access to AD. They're not going to let you I can't create new Medtronic users. Therefore, I can't get to that access token lifetime to change the default timeout. And that default timeout, if you don't do anything else today, is an hour. So my users that are logging into the cluster, and it's really nice to have that device token login, and now I know that they logged in with the same credentials they might use for their email, they got to do that every hour. And I can't fix that because I can't get to that access level, that access token lifetime as a result. And that could mean that you decide that a cluster at a dev level that maybe has no PII, no PHI, nothing important, you give people admin credentials and you can control that at the IAM level of Kubernetes. Or maybe you work through whatever you got to do with your IT providers to increase the access token lifetime to something larger for the purpose of your users. So a lot of ways to handle that, but if you interactively go with this, you might have that timeout limit. So again, I'm going to pause real quick and check to see if there's any questions. Still no questions? I'm amazed because I'm going over some stuff. So great. I feel like I wrote it well. All right. So now I'm going to jump into kind of a new section here. We're going to talk about microservice patterns and scaling microservices. And we're going to go over requirements, how we kind of migrated to YAML, so a little bit about that journey, some more patterns questions. We're going to do a process overview. And then I'm going to talk about how we scale to multi-cloud. What are some of the patterns you need to do to scale to multi-cloud? So first, the requirements going into this is we needed to support Java and .NET microservices. I mean, if you've done some Agile coursework, DevJam, and they have a new name now. I still call them DevJam in my hand, but they have a great Agile workshop. They talk about kind of knowing your customers. And when we did a dojo with them a while back at Thomson Reuters, we had the big pictures of our customers and we described them up. And our customer base here was Java and .NET. And so as much as I love Node.js and Python, I had to accept that my customers were Java and .NET. So think about your customers. We were going to work on Java and .NET microservices. We also had a really strong desire, especially this is not my doing, this is the lead of that team. was a strong believer in Swagger. Document your code with Swagger so your REST API is documented. And he found some tooling that said, if you have well-documented Swagger, you can generate .NET and Java client bindings from the Swagger. Now this is really cool because this means we define our microservice in Java or .NET, whatever's the language that makes sense for that particular microservice. But if I have Swagger, I can create those client bindings so that my tooling elsewhere can use my Swagger service automatically. I'm not writing more code for that. There's not a solution file or a POM file out there for the client bindings. The Swagger gets fed into some tool chains that create the .NET NuGet package and the Java jar files and upload them. And so we started to auto-generate .NET and Java client bindings from the Swagger files. We deploy using Helm and Helm. And the key thing I want to point out here is we started with YAML, and Helm is not all that crazily, people get spooked by Helm. Helm isn't scary. Helm is just a really clever way to automate your YAML. At the end of the day, Helm just outputs YAML. And Helm used to have Tiller, right? That had a rather large blast radius because you have this containerized service, Tiller, that has amazing powers that can do everything. And with Helm 3, of course, they got rid of Tiller. So our Helm deploys the YAML, and the real difference that we saw as an end result when we moved from YAML to Helm was that a lot more annotations. So there's a lot more noise, if you will, to watch what we did in various namespaces because Helm 3 uses annotations to track that kind of stuff. Fourthly, we had Sonar. We kind of went whole hog and said, we want to use SonarQube to ensure that our code has a certain level of quality. So we started to use patterns for Sonar exclusions, right? If we're auto-generating code, like I talked about in that second step, I don't want Sonar to necessarily review that and give tickets back to my users for auto-generated code. And if I have test code, I may not look at test code at the same scrutiny as my running application code as far as Sonar is concerned. So Sonar has a lot of settings for inclusions and exclusions of what is my test folder, what is my source folder. And so we did a lot of work, and this is a team effort between the DevOps folks and the software folks to work up what are those Sonar rules for our different testing. So it was kind of our phased migration. And for a diagram perspective, the top half of the left-hand diagram was how we did it, and the bottom half with the orange is where we went to. So just from a diagram perspective. So with the classic UI, we did a lot of task groups, and we had libraries for Azure Key Vault. Our build pipelines created a drop zip and handed them off to release pipelines. The release pipelines had gates on branches, and we leveraged Kubernetes tasks with AKV. When we went to YAML, we had multi-stage YAML, and we used templates from a control project. Now, this was an awesome thing, because as much as I love the graphical interface and task groups, and I really was a believer, by moving to YAML, I all of a sudden had the ability to share the responsibility for updating common reusable functionality with my developers. They could contribute to how do we build Java, how do we build .NET, without giving them keys to the kingdom with the build pipelines. The YAML Helm environment could be gated on branch. We talked about that. We also found a lot of limitations with the library by creating this abstraction where you had to click to say what are the keys I expose in my library. By switching to the AKV task, we're using a POSIX pattern to pull in secrets from a key vault. And then I talked a little bit about the YAML templates for work item automation on onboarding. So kind of, again, a comparison of task groups versus YAML. Task groups have one version, but they do have history. And the task group permissions are either I let somebody see all my task groups for all my projects in a project, or they can't edit any. So that control was rather limited. And the parameters or the variables that get passed into task group were auto-detected. I had all sorts of hacked little steps just so I could expose a variable the right way because its auto-detection was rather poor. And these are project bound. So I'd have to export and import my task groups from one project to another if I had similar pipelines. On the positives, it has a great visual editor and they're really easy to create. The YAML templates, we had multiple branches in history. I could have a project branch of future work for the shared templates, and we use that. We have PR policies, again, the same scrutiny on code that we use for our build pipelines that we apply to our code for running microservices. A lot more control on the parameters. We can do really fun things like extending functionality and use conditional logic. And you can use these templates for stages, jobs, and steps. We can also pull from any Git provider. This makes it kind of fun. I, for the first time, had cross-project templates. And very soon I expect to have cross-organization templates as well. However, the limitation is there's no visual editor. You have to kind of get past the visual editor. There's some hacks, but the visual, it's code. Code is code. And it's YAML. So, have fun with spaces and tabs. That's YAML. So what's the makeup of a microservice? One of the coolest parts in doing all this work with our development teams, we started to find that a microservice is actually really simple. It's got a Helm chart. It's got the service itself, and it's got Swagger docs used for documentation and autogen. If you want to look at what that looks like graphically, this is it. This is all my folder of any one of my microservices. Is pretty much the code, the charts, the Swagger, and the REST generated notes. And that was all it really had to do. And then our deployment section might vary depending on whether it's going to one cloud or another cloud or on-prem. Kind of the full process from a bigger picture. We'd have a microservice again. This is kind of a deeper dive into what I just showed. We'd have these reusable steps, and you notice that the first top block there for the auto generation needed to use a Windows agent because we're doing Net 451. Well, this is really cool. My builders and my teams would often have MacBooks. And we're using .NET Core. So with .NET Core, we could do on Linux a lot easier. Our microservices were all Linux. We didn't use Windows nodes in our Kubernetes system, but we generated the Windows client bindings from that first step from the Swagger. We'd push our SonarQube results up, and if we had failures, we had decorations that came back and stopped it, so we could quality gate on any of our microservices that way. We'd push up to the container registry, and from there we could do a CD out to Azure Kubernetes service. And we had really cool tooling that the Swagger file got pushed as a config map and mounted onto a containerized Swagger microservice. So our Swagger documentation accurately reflected the services running in a given namespace. We also had a promotion from one area to another. Be cognizant of time. I'm almost out, so I'll try to speed up a little bit. Our multi-cloud pattern was very similar. This just let us scale. And what we're seeing here is more how these things got reused. And so these task groups and templates got reused many times. And what I kind of wanted to show you there with the green dots, so you're going to see probably green dots because it's a big picture, is that this is our charts, containers, and Helm. They were the same. So when a thing got built and how to deploy it, those bits, the container and the chart, maybe not the settings, but the container and the chart got pushed out to everywhere it could be, whether it's RKE for on-prem or EKS or AKS. We went to all the places, and then we have decisions in our deployment pipeline on how to deploy. The other interesting thing is by using an agent pool, this is how our infrastructure team provided us connectivity out to disconnected clouds, to areas that had a much tighter control and we couldn't directly interface with. So the agent pool got given to us by the infrastructure team, and then we leveraged provided agent pool. And that's how we deployed. We also even, and you kind of notice in purple there on the right-hand side, had a very clever way that we had an internal wiki site that wasn't exposed, and we used a private agent to actually push content up as generated from Markdown into that Confluence wiki. And so there was very clever ways we've used pipelines throughout the system. So some of the key differences between YAML, what I'm showing you here on the bottom and on the right is one particular library, and this is the real code for both. I just kind of masked out some specifics. And so you can see how it really translated well. So with the classic UI, which you're not going to get away from, because if you use the Azure Test Management Suite, they still use release pipelines to do automation. But that classic UI we've started to get rid of. It had a really easy graphical interface, but it had to be managed by us. And all the control on those was at the release gate. In other words, build pipelines were supposed to be used or edited by developers, and the release pipelines were to be locked down. That's our gate. With the YAML templates, we far more put the control at the environment level. So the user looking at this right-hand side Azure pipeline, I'm sorry for all the masking, I just have to get through legal on stuff. But the right-hand side, you see there's nothing in there about restrictions. They simply are trying to go to a destination Kubernetes cluster. And that target environment, whatever I've set as the rules on that environment, controls whether or not this microservice gets deployed there. So this created a really nice delineation of labor and control. So all our modern CICD uses YAML. And this really empowers the developers to own their pipelines and contribute to the common templates, and found this to be a very scalable solution for our connected clouds. So some considerations. You want to empowering developers with YAML requires trust. It's hard. I'm at heart a BOFH. I'm a build guy. I don't want to let you see my build files. You can view them, but you can't edit them. It's hard as we grow to allow more people to have edit to that power. I think that's always going to be the problem of ops. And so empowering developers with YAML requires you to trust your developers to do the right thing. You're going to have rules and controls, trust but verify, but it does require trust. Requiring managed agents creates choke points. Don't do that. Don't create pipeline agents that just sit out there like Jenkins dumb slave agents, an old term, but that's what they're called. You don't want to have this private pool of agents if you can avoid it. The only times you should use private agents are if you have controlled environments that you can't natively see from an Azure provided agent. So private agents really create choke points and limitations of scale. Hold on a second, please. Another consideration is that library, and as cool as library is to use your service credential and expose the key vault up as group variables, it creates an unnecessary abstraction. It's really far better to directly access your variables through the AKV task step. And you can minimize your blast radius by having more vaults. Vaults, especially basic vaults, are cheap. Make a lot of AKVs. Make them for every use. Give users secrets policy access to the individual KVs that they need to do. But more KVs is better. Also, libraries requires manual selection and mapping. So if you add a variable to key vault, it doesn't show up in the library unless somebody goes in there and clicks edit and then clicks the little checkbox to show it. If you delete it, you have this hanging Chad over here. Now, a flip side, there are times to use these. And so the times that you'd want to maybe use a group variable is if your code is in GitHub Enterprise or in GitHub and you're using Azure DevOps just for your pipelines. You may not want to put the exact name of your key vault and service connection into your GitHub repo if it's public. Or if your Azure DevOps repo is public, you again might want to use the library so that you're not showing how the sausage is made, where the secrets come from. The secrets are in your code, but you don't show exactly where they're coming from. You're hiding that detail. So that would be a case where I would still use a group variable. Also, you're going to want to minimize your use of build variables settable at build time. Build variables should only be used for, I have a case of a pipeline that has to take a user password for reset. That would be one where I'd let them edit and not persist. But don't try to turn Azure DevOps into a utility Jenkins job. Some of the questions you're going to want to ask yourself are, how do my developers learn about Azure DevOps? As we move people onto the system, thinking about those patterns and practices in writing is a thing to think about. How do we inform but also enforce on patterns? So talking about what you want to do isn't good enough. You need to have pipes and pipelines that have controls. What is our cost model? How do we charge back? If we're going to add users, how do we make sure that the business knows about those charges? Things like Visual Studio Enterprise, which used to be called MSDN, gives you free access to things like artifacts and test plans. Can you use VSE? Where's our compute? Are we going to use parallel Azure pipelines, or are we going to use it on-prem? And where do we deploy? That can help tailor how do I line up projects and how do I give access. And lastly, how do we manage identities? How are we going to let people in? Are we going to use DLs for every team? What's that look like? Some of the growth areas, and this will be my wrap up, is some of the infrastructure. We are still thinking through the right way to expose secrets to pods. There's a lot of options out there, and there's sidecar injection, there's directly accessing Key Vault or HashiVault. So thinking through the right way to do secrets is something that I think we continue to rethink and question ourselves. There's a lot of service mesh options out there. If you're in the Hashi set, console's an obvious, but a lot of people use Istio. And if you use Istio, who controls that? Ingress. Early on, we did Nginx. I think a lot of people do. But then if you have Istio, Istio can let you do Ingress. And I've now become kind of a fan of Ambassador. So there's a lot of answers for how you do Ingress. Again, secrets providers, a lot of secrets providers. In fact, if you're all in on Microsoft, you can use the CSI Secret Store Provider Azure to install an actual CSI so your pods can directly engage with AKV, but then you're kind of married into Azure. What's the proper way to promote releases? That's another thing that you want to think. You don't want to rebuild. The early days, we merge to master and rebuild stuff. You don't want to rebuild your containers. So think about how to loosely couple that so that you can do promotions. And the last thing that we're kind of growth areas is what is the proper way to validate and test things? You can do unit tests. That's obvious. Unit and integration tests, the low layer for sure. But how do I test interrelated microservices? Do I have a string of permutations of what are all the different versions? Do I reject one or the other? Thinking through the right way to validate and test loosely coupled microservices is something I think we still think about. What is the right way to do that? The other thing is you want to ask yourself as far as questions to take away is, can I really rely on a single cloud platform as a service, or do I need to think about multi-cloud? What are my migration considerations if the offering no longer becomes available? What if they take something away? I kind of pick on Google this way. They often do. And then what are the methods of control and auditing? How do we ensure that people haven't changed things or everything's known from where it comes through? One of the ways we did that is we label our containers with the build ID, so I have the traceability from what's running in an environment back to the build that originated it. Now, what does success look like, and how do we do day 2 operations? I see there's a question about hashing. I'll get to that. Who's going to manage this after the fact? The build team may launch it, but who's going to be the ones on the phone if things aren't running at 4 a.m.? And how do we scale? If you're successful with one microservice and one cluster, are you going to do namespaces for each of your teams, or are you going to do different clusters? And what does that look like? How do they interact? And what do those costs look like? Nothing is free. Kubernetes clusters at the cheapest are going to be $100 or so bucks. So you're going to need to think about, how do I control my costs if I do auto-scaling clusters? What is my tolerance for pain? How wide out do I go before I do an alert and go back to the business to say, do you really want us to have an $8,000 a month cluster going on for development? So yeah, I'll get to some questions here. Thank you for your time. I'm going to answer some of the questions here. One was, how do you decide to go Istio over HashiCorp? Sometimes decisions aren't yours to make. And so there's cases where a decision was made for business reasons, and you have to just kind of go with it and accept it. I think teams that would go with Istio over console might be a cost basis, that there's maybe they're worried about the enterprise contracts with console. What exactly will be the data that console sees? How do I review it? Whereas Istio is something that you can get off the shelf and just install. But there's a consequence in terms of who's going to manage Istio. What is the day 2 like? For instance, if Istio is your ingress and exposes your TLS for ingress, who's going to provide the certificates and configure it? And if they have the certificates, do they have the private key signing ability for that certificate? What does that look like? Do I do that in Terraform? Do I pull from Key Vault? That becomes a big question when you do that, as well as how do I configure either one of those? Some of the best features of these service meshes are making sure like your front layer can talk to your mid layer and your mid layer can talk to your database, but your front layer can't talk directly to your database. That's cool, but who's setting up those rules? Who's setting up those meshes and verifying them? Another question was, how do you manage orchestration of multiple independent microservices? That is a great question. And that is something early on we thought about. And so one of those is that you want to put a lot of testing into your pull request level so that if your pull request can build something, perhaps it deploys to a namespace that would verify whether or not it's going to fall down, and try to put as much controls at the PR level so that when it gets merged to your developer main branch, it doesn't take things down. But yeah, there's cases of that today. I'm not going to give you the names, but I have 3 microservices down at the moment in one spot because one thing was dependent on another, and another thing was dependent on another, and another thing was dependent on, say, a Hortonworks stack, and these things have now caused cascading failures. And you just have to make sure that your developers know about it and you alert, right? You want to fail fast, I guess is what I'm trying to say. See if there's any other questions. Thank you very much.